Okay, we're good.
Director's accused, Mr. Brady. Senator Turner.
3.
Back to live television. All right. Okay. For you, I have a gimme, and it's called number 15. For all of you. It's a gift. It's a gift because recently we've been celebrating challenges. This is one of your challenges gifts right here. A free 5 points on the test if you can interpret this. Okay? Of course, you have to interpret it first. Now, f prime is less than 0. Do you know what kind of numbers are less than 0?
Negative numbers.
Negatives. You know what kind of numbers are greater than 0?
Positive numbers.
Positives. Okay. A function has a derivative that is always negative. Therefore, okay, the slope is always negative. Hence, the function must be always, wait, this is the first derivative. Decreasing, right? So the function is always decreasing. Now, which function? What's the name of the function? F prime or f? That means the original function is decreasing, right? That actually means that the first derivative picture is always located below the x-axis. Yeah, we'll get into that in calculus. Okay? Graphing f prime and f double prime, that kind of stuff. Okay? So this means that the original function is decreasing. If the double derivative is always positive, that means that, okay, what's concave? The original function, because it's two derivatives away from the original function, right? Okay? So the original function is concave up. Okay? So we're just looking at f. So f, first derivative, oh, decrease. Second derivative, oh, concave up. All you have to do is draw something that is decreasing concave up. Matter of fact, there's a great example from this year that we've done. E to the negative x is a great one. Very nice, Jordan Flowers.
Oh.
You know what?
Really? No.
I never give you any plus 10. This is grade so high. I never
It's
give
true.
you- That was good. That was good. I'll give you plus 10.
I could use it.
I gotta give you one every once in a while, right?
Yeah.
Kind of doing it all.
I've never had anyone in calculus ever get that right. Anyway.
Okay.
That's the teacher.
All right. Y equals e to the negative x is a classic example. You do not have to put the equation, by the way. Just put the sketch. Okay. If anybody drew a curve in the box
Good job, Jordan.
that was decreasing but facing up, then you got it. Okay, that's it. Okay, I'll give you a graph on the test. You can draw it with an asymptote. You can draw a curve that doesn't have an asymptote but decreases forever. That's okay. It doesn't have to have an asymptote. You just put it somewhere. Okay. I'm just looking for the curvature. Jack Weston Bell. Right. Okay. So anyway, all you have to do, I'm just going to look for a curve that matches that right there. Does that make sense? Okay. I'm going down, but I'm facing up at the same time. Just like that.
Okay.
That's it. Okay. Okay.
Any of those will work.
Hey, yep. You're just, yeah, any of this. You're just proving, oh, Mr. Wade, I understand that the first derivative measures slope, but the second derivative measures concavity. That's all you're doing right there. Very basic one. All right. And that ends derivative world. Now it's time to go to anti-derivative world. Okay. Let's see about that. Okay. All right. Now, perhaps you remember the rule. First of all, by the way, let's note up here. 1 over x is actually the same thing as what? X to the
Negative.
negative 1. And the cube root of x is the same thing as x to the what? X to the 1/3. Okay. Side note right there. Now, if you remember, to do an antiderivative of the power rule is just the opposite of the power rule. Okay? Backwards and opposite. So, first things first, what is the power right here?
1.
Right now it's 1. If you do the antiderivative, it will go up to 2 and divide by the something u power?
New.
U power, right? Okay, very good. Okay. U power. All right, so you get 5x squared over 2. Okay? 5 halves. You can do that as well. Now, next one, x to the negative 1 power. If you add 1 to the power, you're going to get x to the 0 over 0. Uh-oh, that can't be. This is a special rule, right? Okay? If it's 1 over x to the first, that's the special case where you don't add 1 to the power. That's a dead end, all right? The best way to do this is to remember whose derivative is 1 over x.
Natural value.
Natural log. The derivative of natural log, isn't that just 1 over the base? Okay, so that would work, but don't forget something solute. Absolute values. Okay. Okay. And there you go. All right, so far so good. Okay.
Do you handcraft antiderivative problems too, or is that just?
They pretty much fall into place no matter what you do.
Okay, because I was thinking if you just like, how would you do that?
Yeah,
You
I
just,
mean,
do
pretty
that
much you can make
thing?
up anything and it'll work out fine.
Yeah.
Yeah. Now, there are some in calculus, when we get to harder ones, you have to handcraft those.
Okay.
But for the easy ones, I can just put down any random numbers and they work, yeah.
All right.
And of course, the front page, that's a lot of handcrafting on the front page of the system.
Yeah,
That's a
that-
whole bunch of it. Hours of handcrafting. Okay, now, x to the 1/3 would become x to the 4/3 over 4/3. Ooh, I see a reciprocal in our future. I spy, who's ready to play I spy? I spy reciprocal. Okay, plus C or not?
No, it's not asking for,
Antiderivative is not a plus C, is it?
Integration.
Right, integration, yeah, the
there's a
plus C.
lot of I's in this.
Okay, there are, yeah, there actually are, yeah. Intersection, inflection, okay, all of
Make a
those.
song out of that.
Integrate, okay. So, the antiderivative is just going strictly backwards, don't put the plus C, so you get, here's your final answer, 5/2 x squared. I kind of like the, putting 5/2 as a coefficient, but you can keep it on top if you want. Okay, don't forget the bars, that's a -1 without the bars, so put the bars in it. And reciprocate. 3/4, oh, wait a minute, we came from radical form. If you really compress Mr. Wade, you could put x to the 4th power in cube root. There we go. Okay, and that's good right there. Okay, perfect. Okay, all right, so just a simple rule to remember, just don't apply it to x to the 1st on the bottom. Now, if it's x to the 2nd on the bottom, you can add 1 to the power. But when you see that x to the 1st on the bottom, do the natural. Okay? All right, now 17. Ooh, what's this fancy symbol? Okay, that is known as an integral, symbolizing integration, right? So that's the integral. Remember that that is the stretched capital S from the Latin word summa, sum, right? The sum.
What's synopsis?
Okay, a synopse is the Greek word for synopsis. That's the sigma. They mean essentially the same thing. Okay? So that's synopse, that's summa. Greek, Latin. All right? Now you can refresh your friends. At parties. All right. Did you know that the integral symbol came from? Okay. So let's take the integration of this right here. But first, it's not integration ready yet. Okay? Let's rewrite this. Don't float the 5 up to the top because you're going to create a 20. That's no good. 4/5 is not 20. Leave the 4/5 intact and only move the what? The x, and it will become x to the -3. Okay? Minus, okay? Move this one as well. But Mr. Wake, you taught us that 1 over anything is just a natural law.
No, it has a radical.
I set this up to see if anyone would fall for it, actually. Okay? Don't fall for it.
Natural.
I'm not trying to fool you, but it's going to be on the test, right? So don't make that natural log squared. You can't do that. It's actually x to the what power? -1/2. Let me tell you something. That's not -1. So that's not the natural log rule, right? Okay? And then plus 2. Okay, now let's integrate. Now when you integrate, which is going to be our next step here, let me put it right here. When you integrate, you will now drop the
Yeah.
dx and drop the integral. Yep, because now you're actually integrating, so you're using up the integral. So integral and the dx are a package deal. They're gone. We'll prove what they mean in calculus, actually. All right, and that would go up to the what power? Negative
Second.
2, yep, -2, divided by the new power of -2. Okay, x to the -1/2 goes up to x to the 1/2 over 1/2. And you just guess this one. Whose derivative is 2? 2x. Don't forget the plus c, that'd be the best one.
Okay.
Okay, or plus k, sure. Okay, this is integration, so put the plus c, all right? And remember, if you forgot that the derivative of 2x was 2, I don't think you would, but you can always do this by the rule. Isn't 2 technically 2x to the 0? So it is 2x to the first over 1, right? Okay, that works. Okay. And let's just clean this up a little bit and make it perfect. How about a little cross cancellation here? Okay, and it's going to be negative, we'll put the negative. So the coefficient, wouldn't it be negative 2 over 5? And the x to the negative 2 will
Go back down.
down to the bottom. And the reciprocal of 1/2 is 2, and x to the 1/2 is, okay, square root of x, and then plus 2x plus e. Done. Okay, and you check your answer. Take the derivative of your answer and see if you get the original that I have, and it works. It's like Mr. Ray dropped the key next to your desk. Oops. Not the fake key.
Yeah, no.
Yes. Like that poor set that. Does anybody see my keys? Anybody? I seem to have misplaced my keys somewhere. Where are my keys? Okay. Now for this part, you have to know your trigonometric derivatives to know their antiderivatives. Integration. Okay. All right. Package deal. U is probably the second most common thing used in integration to x. We'll see that next year. So, whose derivative is sine? Hashu!
Negative cosine.
That's the first one.
It's a competition. All right. That was real. I exaggerated a little bit to get it out of my system. But all right. When this marker ink goes right up your nose. Okay. So it'd be negative cosine. Isn't the derivative of negative cosine going to turn into positive sine? Okay. Whose derivative ends up being cosine? Sine. And whose derivative ends up being secant squared? Tangent. Don't forget a plus something. See, okay?
Not something.
Okay? Something, so that you don't get the -1. And remember, you can always remember this. Remember what the derivative of sine was back in the old days? Derivative of